హౌస్ లోకి మనం ఎక్కడి నుంచి అయితే డేటాను తీసుకొస్తామో వాటిని మనం సోర్స్ డేటా అంటాం. వేరే మన వేరే హౌస్ ని టార్గెట్ అంటాం. సో బేసిక్ గా ఏంటంటే మనకి సోర్సెస్ వచ్చేసి ఎప్పుడు కూడా OLTP డేటా బేసెస్ ఉంటాయి అండ్ ఫైల్స్ ఏదైనా ఉంటే ఫైల్స్ కూడా ఉండొచ్చు. సో ఈ సోర్స్ డేటా మన డేటా వేర్ హౌస్ లోకి మనం ఎక్కడి నుంచి అయితే డేటాను పుల్ చేస్తామో ఫ్రమ్ వేర్ ఎవర్ వి పుల్ ద data into the data warehouse. So that we call it as source data. So and the databases or files that have this data are called data sources. So so the data profiling means it is the process of analyzing the source data. So that means so if you look at this OLTP or databases here, so whatever the databases or files, whatever from wherever we have to pull the data, the process of analyzing that data is called data profiling. And that means, let's say, if you are looking at this OLTP database, so when I say database, there is a possibility that there are a few hundreds and thousands of tables in a OLTP database. And let's say I want to identify on how to bring the data from this source system into our warehouse. So that is where I was that is what I was talking about. So basically, when you do the data profiling, you can answer many questions related to your source data. So we have to do the data profiling before pulling the data into the data warehouse. So yeah, any questions?
Sir, can you repeat the last point regarding data profiling?
Yeah, so data profiling is nothing but analyzing this source data.
Okay.
Source data in the sense, for us, the source data will be the data base or data file from which we are pulling the data into warehouse, right? So that is called data profiling. And why do you need data profiling on source data? So I have a reasoning here. So if you do the data profiling on the source data, so you can understand the structure of the source data. I mean, what are the tables, what are the relationship between them, what kind of data do we have in the source, how many distinct data types are there. Do you know what data types? About data types? Like if you declare a table, I mean, if you create a table, basically on that table, while creating the table, you will define, okay, create table name, and then column name and its data type. So every column will have a data type in a table. So, one sec. Yeah. So when we analyze the source data, so we can basically understand what are the different tables that we have in a source database, and what kind of how many tables are there in the source database, how each table is related to the other table, how to fetch the data from the source data and all. So basically we can answer so many questions. So it is not just that the ETL will do everything. Hey guys, I can hear some echo. If you can mute from your side, that would be great. Okay. So when I say, okay, the ETL process is nothing but extraction of data from the source databases and transforming the data and loading into the warehouse, this ETL logic is to be written by the ETL developers. So if they want to write the extraction logic, they want to first analyze, they have to analyze Okay, how to pull the data, how to extract the data from a source system. So to understand the extraction logic, first of all, we need to have a good understanding of the OLTP database structure, tables, and what kind of data is in there. Because when we build a data warehouse, we bring only those columns or those tables or the data that is the only data that is required by client. Whatever is in OLTP, we don't simply blindly bring all of them. It is not mandatory to bring every single piece of information from OLTP database. So whatever is required to the client, we have to bring only that. So in the process of bringing that information that is required to client, we have to first analyze whatever the information requested by client. Where is that information in the OLTP databases or flat files, etc. So to understand the data and the process of analyzing the source data is called data profiling. So basically, when you do the data profiling, you can answer many questions like how many distinct data types are there in the data source. So for example, let's say if I have a table or if I have 100 tables, each table let's say will have 10 columns. Okay, so 100 tables will have 1000 columns, 100 into 10. So out of those 1000 columns in my source database, how many distinct data types are there? Out of those 1000 columns, how many of them are having the data type as a date? How many of them are numeric? How many of those columns are characteristic? So on and so forth. So I can answer those kind of questions like how many distinct data types are there? Or I can also answer what is the average length of a column. The average length of a column in the sense, for example, in each table, when we define the table, we give the column names and the data types and their length and precision. Hey, one thing, how many of you are familiar with SQL? Or rather, I should say, how many of you are not familiar with SQL? So let me start. I know few people here who does know it. Amulya, do you have enough idea on SQL?
Yeah.
Okay. So you know what is the data type and stuff like that, right?
Yes.
Okay, cool. Thank you. And I know Nitin knows it, Pawan knows it, Neil knows it. Vamshi?
I know, sir.
Okay, cool. And then you can stop me right there when if you don't understand what I'm talking about. So, yeah.
Thank you.
Okay, no problem. Yeah. So when you do the data profiling, you can find out the average length of a column. Or let's say you have a table in which there are 10 columns, out of which you want to figure out in one particular column how much is the percentage of null value. Like let's say in a particular table, we have 10 columns. Out of 10 columns, I want to figure out null percentage on a specific column. So, for example, in a table I have 100 rows, and in that specific column has 40 null value has null in 40 records. So the percentage of null values is 40%, right? So for that particular column. So this way I can calculate the percentage of null values or percentage of repetitive values. Repetitive values meaning out of 100 records that I have in the table, in that specific column, if the values are repeating, for example, if you have to analyze a table in a OLTP database, So there is a products table in one of the databases, the OLTP database. In this table, I want to figure out how many distinct values are there. Let's say there is a column called product category. In this product category, how many distinct values are there? You can see most of the values are repetitive here, right? So if I write a query, okay, on this products table, select distinct product category from products. So if I run this query, now I got only like 1, 2, 3, 4, 5, 5 records. But if you look at the data, in this particular table, I have a total of 72 records. But out of 72 records, I'm getting only 5 distinct values in this column. So the percentage of repetitive values here is, like, if out of 72 records, only 5 distinct values are there. So that means around 80-85% of them are repetitive, right? So this way, we can calculate, we can answer any questions related to the source structure. We can answer any questions related to the source database when we do the data profiling. Usually this is done before the data warehousing is built. So data profiling will be done before, at least before the ETL logic is defined, this data profiling will be done. And it will be done in the initial stages of while building a data warehouse. So yeah, so this has to do with the ETL guys. Sometimes, the ETL developers may also have to do data profiling, but most of the times there will be data architects who does this job for you. Data warehouse architects or data architects who understands the source data and also analyzes the end user's requirements, client's requirements, and then try to match between them by analyzing the source data. He will then come to an understanding of how to fetch the data into data warehouse based on the client requirement. But the information has to come from OLTP databases or files, right? So an understanding of source data is very important. Or let's say in a OLTP database you might have hundreds of tables. So you may want to analyze, okay, what is the relationship between particular two tables? So, oh my god, one sec. Ramesh, tell me. Ramesh, tell me. Ah, 8:30. Okay. మీ దగ్గర యుఎస్ నెంబర్ లేదా? ఓకే. ఓకే, నెక్స్ట్ వచ్చేసి ఇప్పుడు డేటా ఎక్స్ట్రాక్షన్. సో డేటా ఎక్స్ట్రాక్షన్ అంటే ఇట్ ఈస్ ద యాక్ట్ ఆఫ్ ప్రాసెస్ ఆఫ్ రిట్రీవింగ్ ద డేటా అవుట్ ఆఫ్ unstructured, poorly structured or structured data sources for further data processing or data storage. So to keep it simple, the data extraction is nothing but, okay, once we analyze the source data by doing the data profiling, we got an understanding of how the source data is, and then we write some ETL logic. In the ETL, it stands for extraction. So data extraction is the process of extracting the data from the source databases or source files. So that involves extracting from different databases like heterogeneous databases, and maybe you may want to pull the data from not only databases. So you may want to pull the data from files. You may have to pull the data from web pages, emails, anything. So basically, these sources are categorized like. So you might expect something very unstructured, poorly structured, or structured. So for example, a database table is a well structured because when we define a table, we clearly say, okay, in this table I'm going to have these many columns, and we will specifically define, okay, what is the name of each column, what is the data type of the column, what is the length of the column, are there any constants on this column. So this way we clearly define the table structure. So that is a structured data source. And you may have to sometimes pull data from a poorly structured. Poorly structured in the sense, for example, some CSV files, Excel sheets basically, or some other file sources. And maybe unstructured also. Unstructured in the sense that you may have to pull the data from a text file or some web pages or email. So you may have to deal with all these kinds of sources, so that when we extract the data, we do the extraction mainly to data stores to store the data that we pull from source into the data warehouse database, and then sometimes the data that we extract from source may be stored in some temporary space and may be further processed. But whatever it is, we are just talking about the process of extraction. So, process of extraction is nothing but retrieving the data out of data sources. The data sources can be unstructured, fully structured, or structured. And here I gave some examples of the data sources from where you may have to pull the data from. So, you may have to pull the data from databases, OLTP databases, etc. Text files, .txt files, or .csv files. .csv files is like, let me show you one example.
Excuse me, sir.
Sorry?
Sir, when you said structured or unstructured, can we say that structured means non-uniform data?
Yeah. So when we unstructured or poorly structured?
I mean, those are not uniform, right? Is it correct if I say non-uniform data? I mean, data of different types, different data types.
That is quite accepted, right? So the data types, there will be definitely different data types in any data source. Like if you say that, okay, I have a table. In a table, not all the columns will have the same data type, like we are seeing here. Fewer numbers, fewer characters, like this, right? But sometimes in this table, fewer dates. But sometimes you don't even know what is the data type of it. For example, I'll show you one data file. So here I have some employee information. Like there are around employee records for around 10 or 12 employees. And if you see, and if you look at this data, what kind of data are we seeing here? Whether it's characteristic or number. So this is not defined in this sheet. The only thing, yes, we have got some record in this. So while pulling the data from these kind of files, we may have to define our own logic while extracting the data from these kind of files. But these files will be handed over to you. It is the ETL guy's responsibility to pull the data from these kind of files as well. At least this has got some small, some kind of structure to it, but it is poorly structured too. But sometimes you may be simply given something like, so this is kind of like a file given to me with some product ID and its price. So I don't know what kind of data types they are. So it's really unstructured, right? So I have to give a proper structure to it. All I'm getting is from this file. So I may have to load the data from these kind of files as well into my warehouse. So you can expect the data not only from the tables of a database, you can expect the data from the files, CSV files, text files, XML sheets, anything, COBOL files. So if you want to know about exact meaning of unstructured, poorly structured, and structured with examples, you can just Google about unstructured data, poorly structured data, and structured data. And that should give you models. But for now, all you need to know is, okay, what is data extraction? Data extraction is the process of retrieving the data out of data sources. And those data sources can be either unstructured or fully structured or structured. Okay. And here are few examples of where you may have to pull the data from. In a data warehousing project, you cannot always expect OLTP database. Maybe 80% of the data coming from the databases. Maybe some 20% is coming from text files, CSV files, etc. or COBOL files, XML files. Wherever it comes from, you have to extract it basically. Wherever is the data stored, you have to extract from that data source. Now, here, let us talk about data staging area. Yesterday I was showing you some traditional anything like bottom up or top down. In both, you have something called staging area. Now we are talking about extraction. So let us assume that I have extracted the data from the OLTP databases as well as, let's say, from some files also, like text files or CSV files. I have extracted the data and loaded into the staging area. So what is staging area? That is what I was explaining here. Basically, staging area, especially in terms of data warehousing, a staging area is an intermediate storage area between the sources of information and the data warehouse or the data mart. So basically, before loading the data into the data warehouse, while we pull the data from source tables or source databases and files, we first put it into a staging area where we may have to apply some calculations, some cleansing activities, maybe some manipulation of data happens on top of the staging data. So basically, we don't directly load the data from OLTP to or files directly to warehouse. Instead, we may first load it into a staging area where we will apply some of the cleaning activities, some of the calculations, applying the business logics on top of the data. So to do all these things, we usually choose one staging area. The data is not permanent in the staging area. We keep the data in the staging area up to only when till the data warehouse gets loaded. So let's say I pull 100 records from some OLTP source today. I'll put that into the staging area first. On top of it, I will apply my business logics and stuff, and then I'll load it into warehouse. In warehouse, once those 100 records are loaded, those are permanent in warehouse. But then later on, maybe tomorrow, while I'm extracting again, I might remove the yesterday's 100 records that were loaded into staging area. So usually the storage in the staging area is temporary. Okay, and that could be anywhere between 1 day to usually 1 month most of the time. So, but the most possible staging is for 1 day, the least one, and maximum you can keep up to 90 days. It depends on how many days you want to stage it and what is the exact purpose of staging. Usually the purpose of staging would be you don't want to directly dump the data from source database into your data warehouse database, because data warehouse has its own rules, its own principles, its own data structure, and its own logic that we may want to apply. So instead of applying the data logic on top of the source data directly, we first extract this data from the source databases and load it into an intermediate storage area called staging area. It is also a database. Staging area is nothing like a hard disk or something. It is also a database. It's not like files or something. So that means it will also have tables in it, a staging database basically. But then once we say, okay, we are loading into tables, obviously that will be in a database like Oracle or DB2 or something. So usually the staging tables will be there in the staging area. So first we load the data from the OLTP databases or files into the staging table, and from there we will load it into the final data warehouse table. Okay. So when I say extracting the data, that doesn't mean that I am not doing cut paste. I am not doing cut paste from source into warehouse or staging. When I say extraction, I am actually copy paste. It's not cut paste. You know the difference? So when I say copy paste, the data that I am extracting into my staging area will also be there in the OLTP database. If I say cut paste, that means I am removing from here and putting it here. No, it's not the case. The case is copy paste. I am actually just retrieving the data from here, the OLTP database or files, and loading it to staging area. But still the data will be there here also. Okay. So, okay, now the staging area is like a temporary storage area, and we usually keep the data in the staging area till we load the data warehouse. Data into the data warehouse table. After we load the data into the data warehouse table, you can remove it at any point of time. And that depends on how much time period you want to give to store the data in the staging area. And usually the process is like today, let's say I pull 100 records into from the source into the staging area, and once those 100 records are loaded, and in the next day's process, tomorrow also I will be processing the same ETL process. I will be executing the same ETL process. So maybe tomorrow I'll get 100 more new records or 50 more new records. But then the old 100 records are still here. So while extracting and before loading into the staging area, I will remove those old 100 records and put these new 50 records into it. So this way I keep only data temporarily in the staging area. But when the data loads into the data warehouse, that is permanently stored in there. Next, data cleansing. So data cleansing or scrubbing or cleaning, whatever it is just the process of detecting and correcting, and sometimes if correcting is not possible, removing correct or inaccurate records from a record set, table, or database. So why do we data cleansing? So when we say, okay, we have OLTP databases, the data in these databases may be of good quality or may not be of good quality. So we may have to do some data cleansing on top of the source databases. But you know what? This data cleansing is mostly done by the data quality team. So if you guys remember, we usually fill some forms online. So some inquiry forms or some forms for downloading a software, they might ask us to fill some information, and we don't have that much patience, or we don't have that much time, or we don't want to give the right information. So we simply just type in some junk information into those forms and simply click on download. Right? So basically, that is a very valuable information for the organization. They want to know, okay, who is the customer who downloaded a particular software, and they may want to follow up with you for the process of further buying. But you want to escape that. Usually we want to escape that because we don't want someone to call us or disturb us with continuous follow-up and all. So we usually give some junk data. But then that data will be stored in the database, OLTP database of the transactional database of their organization. While storing in there, usually may not be all the records will be stored. They know that the data quality team knows, okay, which is a valid record, which is an invalid record. So they will do, if the value is correctable, that means let's say if someone by mistake typed the city as Australia and missed some one or two letters in there, or input something like country like Australia. So let's say if someone is typing, so they type something like this. So by mistake, let's say they typed it. So we may correct it, right? But if someone says my country is something like this, I don't know what it means, right? So these kind of junk data may not be correctable because it is not in a good form. But this kind of data which was earlier having some typos can be corrected. So data cleansing involves a lot of things like I was explaining here. So data cleansing is a process of detecting and correcting. If correction is not possible, you may have to remove that record. So that means corrupt records or inaccurate records can be either removed or corrected from a record set or a table or a database. So, so in a database we might have so many tables, and in each table you might have so many number of records. So it may be the process of correcting the data in those databases or data sources. So usually this is done on the top of OLTP databases. Like we, as a data warehouse developer, we might expect like above 90% quality data from the source system. So we don't have to worry much about data cleansing, but maybe at times we may have to apply some data cleansing rules on top of the data that is coming from source. Maybe in source, like I said, 90% of data is good, but 10% we may have to correct while doing the ETL process. So we may have to come up with some logic to correct the data automatically based as per our standards. But usually this is done on top of OLTP databases, and there will be a separate team for data quality monitoring. So you don't have to worry about it. But just keep in mind that sometimes you may have to do the data cleansing as well. So next is data integration. So data integration involves combining data residing in different sources and providing unified view of the data to the user. So basically, when we say, okay, we pull the data from different OLTP databases, the data types and the databases may be not same. They may be different, and files and all. So it will have different data types will be supported by different databases. But when it comes to the warehouse, data warehouse is one data warehouse database. So from wherever you pull the data from, that doesn't matter. So finally, while showing it to the end users, you will put all the data into one form. Maybe here in one database, you may be calling your SSN number as a characteristic, and here in one database, you may be calling the SSN number as a number. So while loading into the warehouse, you may want to convert the number into character or character into number. But finally, when presenting to the end users, that SSN number will be presented in only one form, whether it will be numeric data or characteristic data, based on the type of information that will be there in it. So data integration is like removing those kind of data inconsistencies while pulling the data from multiple sources and providing the information in a unified view to the end users. And data aggregation. Data aggregation means while pulling the data from these OLTP databases, we may be having a very detailed data. For example, I have in one of the databases, I have a table called sales table. In this, you get the data of the table. It is giving me very detailed information. Okay, there is a product ID called 13 that has been purchased by so-and-so customer ID on so-and-so date through so-and-so channel and promo. And this is the quantity, this is the amount sold, and invoice has been raised on so-and-so date. So this table is in very detailed format. But I may not be interested on each day what happened. I might say, okay, I want to store information at a month level. I'm not interested in each day. I want to store the data in a month level. Month level meaning in a particular month, how much is the quantity sold and how much is the amount sold. That's what I'm looking for. I'm not interested in what product has been purchased or who is the customer, what is the exact date and all. I'm interested in, okay, in the month of March or in the month of Feb in 1998, how much is the total quantity sold and amount sold. That's what I was looking for. So maybe while in the source, we might have the data at this very detailed level, but when it comes to data warehousing, we may sometimes have to load the data in a summary format. even though the data will be coming in a detailed way, you may have to summarize it and load it. And usually there will be aggregate tables also in the warehouse. So while loading these aggregate tables, we do this kind of data aggregation. And this will be done to increase the performance of the reporting. So while data has been, when the end users run their reports, if they run the reports at month level, for example, I was saying that I want to store the data at a month level instead of day level. Even though the data is at the day level in the source system, I might want to store the data at month level in my warehouse. And while end users run the data, run the reports at month level, the query can directly run against a monthly level table instead of a very detailed table, so that the reports will be fetched faster. So let's say if you have 100 records that belong to a particular month, whatever is the date, if there are 100 records in a sales table that belong to a particular month, then how many records you might expect if you aggregate the data to a month level?
Josh?
Yeah.
Repeat it once again.
Yeah, the question is, let's say we have 100 records belonging to a specific month in the source database. If I say, okay, I'm loading the data at a month level, I want to aggregate the data. So how many records you might expect for a single month?
Just one.
Yeah, so those 100 records now will be reduced to one record because I will summarize the data. So the number of records will be reduced. So obviously, while retrieving the data from aggregate tables, the performance will be faster. So that's why we maintain few aggregate tables as well in the warehouse. But that doesn't mean that we don't maintain the detailed tables. That means daily level data will also be stored in the data warehouse. Also, aggregated data will also be stored in the data warehouse. The process of aggregating the data is called data aggregation. So, which might include applying some aggregation rules such as count, sum, min, max, etc. So, one second. AJ. Good evening. I'm good. So, are you logging in? Okay. So, you're able to connect? Yeah, just when you click on this virtual, just click start. Do you see something start there? A green arrow? No. Is that saying show or start? Okay, just click on that arrow. And you should see your XP machine. Yes. Okay. Yeah, you know what? You can just see what you have in that folder of yours. Do you see the folder? Customer_J? Okay. Yeah, I'm in a class, but I will be wrapping it up like in 15 minutes. No problem. In the meantime, you can do whatever the changes you want to do. Okay. Okay, no problem. Yeah, so data aggregation might involve applying some aggregation rules such as count, sum, min, max, average. There are so many aggregation rules that you may want to. And data transformation. Data transformation is another topic. So far we have been talking about data extraction and data cleansing and stuff like that. Now we are in the process of discussing the transformation, data transformation. So data transformation stage applies a series of rules or functions. You know what? Data transformation is nothing but data manipulation. So while loading the data from the OLTP databases into the staging area or into the data warehouse, so we transform the data as per our requirement. So we usually do some calculations on top of it, or we manipulate the data. We don't straight away copy paste. I mean, it's not just like, okay, the number of records or whatever the number of tables that I have in a database. I don't simply copy all of the data in those tables, or all the table information may not be fetched. Or even within a table, I may not want all the columns to be fetched into my warehouse. Let's say in a particular OLTP database, I have a table in which there are 10 columns. I may not want to pull all the 10 columns into the staging area or warehouse. I may want to pull only 3 or 4 columns from that particular table. So data transformation is something that you do in between extraction and before loading. I mean, after the extraction of data, you transform the data and load it into the staging area or warehouse, whatever. So transformation is anything that you do apart from copy pasting. So if you say, okay, I am not interested in any information of data, all I need is some database that is to be replicated as I want everything that is stored in this to be pulled into some other database. So if I say, okay, copy paste, then that may not include any transformation. But other than that, if you are not copy pasting, if you are not replicating the same database, replicating all the tables, all the columns in those tables, then you are definitely doing some transformation. So transformation is manipulation of the source data before loading into the warehouse. So we do a lot of manipulation of data. There are so many transformation logics that we may want to apply on top of the data that is coming from source. So while pulling from source database, we might apply a lot of transformation logics. So there are a variety of transformations that we may want to apply. And believe me, all the ETL tools out there in the market provide a variety of transformations to apply the transformation logic based on your requirements. So for example, I'm getting the source data. Let's say I have a products table in one of the source databases, and I want to pull the data from this table into my warehouse. But I don't want all the columns of this table to be moving to my warehouse. I may want only like 5 or 6 columns, and then there are like 72 records in this table, and I don't want all the 72 records to go into my warehouse. I may want only those records with price greater than like 100 or maybe 150. I want to filter out the data and send only those records that satisfy my business criteria. So anything that you do apart from copy pasting, if I would have copy pasted this whole table into my warehouse, then there is no transformation involved. It's a straightforward copy paste. But other than that, if I am playing around with the data in between, then that means I am doing transformation. And transformation includes a lot of things like filtering of data, taking only the required columns, or translating the codes. Maybe here you can see that there are so many code values like product weight class, unit of measure, product pack size. If it says unit of measure is U, I may want to load into my warehouse something else. So similarly, if you see something customer's information, maybe in the customer table there is something called customer gender, which is just showing M. Maybe by loading into my warehouse, I may want to convert it into M is for male and F is for female. I want to convert like that while loading into warehouse. So anything that I do in between after extracting the data before loading, whatever the manipulation I do, that's called transformation. And here in this picture, you can see that ETL is involved here, here, and here. What does that mean is, ETL is a process where we extract the data from any data source and transform it as per our requirement and load it into a target. target could be a staging area, or we may want to extract the data. We first initially extract the data from source systems or files and load and transform the data and load it into the staging area. And from staging area again we will extract the data from staging area, apply few more transformation logics, and again load into the warehouse. And from data warehouse we might again extract the data and transform and load it into the data part in this kind of bottom-up, top-down approach. Okay. So wherever you say ETL, the T stands for transformation. That means you are doing some manipulation on top of the data before loading it into the target. Any questions on this? Data transformation. And here in this material given so many examples which I was discussing about so many of kinds of transformations that we might apply. So usually in Informatica apply all these kinds of transformation logic. So in Informatica there are a lot of variety of transformations available. Not only in Informatica, in any ETL tool, even in OWB, Oracle Warehouse Builder, ODI, Oracle Data Integrator, Data Stage, any ETL tool offers a lot of transformation that you may want to apply on top of the data that you are pulling from source. So we do the transformation of data before loading into the warehouse. So here I put it in short. In simple language, transformation is the manipulation of extracted data before loading. So we extract the data from the sources, and before loading into the targets, we do the transformation. Any question on this? And then data loading. Data loading is nothing but we will load the extracted data after transformation. We load it into our target. The target could be a staging area or a data warehouse or a data mart, anything. So we load. Okay. Now I want to go in depth of the process of extraction and the process of loading. Okay, transformation we know we do in between. After extracting the data, we transform it, we manipulate the data as per the requirement, business requirement, and then load it. Okay. While extracting, I have few questions for you guys. Let's say I have a database in which I have one of the tables in which I have 100 records today. So today I will execute my ETL job. What does the ETL job do is it extracts the data and transform it as per the logic that I defined in there and load it to the target. Okay. Now, let's say today it has extracted 100 records, and tomorrow I have got 50 more new records into the table. So that means in total there are 150 records in source. So let's say now next day when I execute the ETL job, do you think that it should again pull those 150 records, or is it sufficient if it pulls only those new 50 records? Did you understand the question?
I think it should be okay if it pulls 50 columns, the extra 50 columns, 50 rows.
50 rows. Yeah. Yeah. So that means definitely we will not be interested to pull old records unless and until there is any change in the old records. Right? So once we pull those first time we pull those 100 records into the target, so those 100 records need not be processed again. So only we can concentrate on those and on any new records every day. And maybe if there is any change in the old records, then we may have processed them again, because we want to update our warehouse also with the latest information. So unless and until there is no change to the old records, you don't have to pull them, and new records always to be extracted. So this kind of extraction of data is called incremental extraction. incremental extraction meaning we extract only those records that are either newly inserted or any old records that are updated. Only those records to be processed every day. If I say I have 1 million records in a table, I don't have to pull all 1 million records every day. Maybe tomorrow there may be another 10,000 added to that. So I'll pull those new 10,000 records. And maybe there are some 5,000 records, old records have been updated. So I'll pull only those old 5,000 records plus that new 10,000, 15,000 records. So this way I do the incremental extraction every day. So this will reduce unnecessary processing of millions of records every day. Because if there is no change to the old records, you don't have to pull them unless and until there is something that has changed. So this kind of extraction is called incremental extraction. So there are two types of extraction. One is full extraction, one is incremental extraction. Full extraction meaning regardless of whether it's a new record or an old record, it doesn't matter. You basically do the complete full extraction. That means every record in the source system will be pulled. But that full extraction you do only for the first time. While loading the data warehouse for the very first time, you may have to pull all the records in the source system once. And from the next day onwards, you can bring only the changed data. That means either newly inserted records or any old records that have been updated. You may want to bring only that data. But initially we do a full extraction, that's called initial extraction. And later on we do a incremental extraction. That is incrementally pulling the data. And also I want to emphasize on loading. While loading the data into the data warehouse, let's say I have on the first day I pulled 100 records. So I will insert those 100 records into data warehouse. Next day I have another new 50 records. So I will insert those 50 records into the warehouse. And I have some 10 old records have been updated. So again, should I insert those 10 old records again, or should I update them in the warehouse? Because those are already loaded into the warehouse earlier, but just because there is some change for those records, I want to process them again. So this time should I insert them again, or is it enough if I just update them? Did you understand the question? Hello? You guys understood the question? So the question is, I have processed 100 records today and they have been loaded into the warehouse. Let's say the next day there are 50 more new records in the source system. So I am processing all those 50 new records and they will be loaded into the warehouse. Right? Let's say there is a change to a old record. So 10 records are actually updated in the source system. So you may want to pull those 10 records because they have been changed. But those 10 records already exist in warehouse, but with the old data. So is it enough if I update the records that are already here, or if I have to insert again those 10 old records? That's the question.
Updating should be fine, Raj.
Sorry?
Updating should be fine.
Yeah. So it depends upon you whether you want to keep the complete history. Whether you want to keep the complete history, that means, let's say if an employee location is, for example, right now it is in Hyderabad. So while he is working in Hyderabad, I entered one record for him. Let's say later on he changed it to Bangalore. So maybe I want to insert one more record because I want to keep the complete history for every employee. Even though he changes his location, I may want to enter a new record because he changed his location. Or if I'm not interested about where he is working on, I'm not interested about his location, I might just simply update it. Either way, you can, if you want to maintain complete history, you can insert again and again. If you don't want the complete history and you just want the latest information of where this particular employee is working, then you may want to update the existing record. So it depends on how you want to load the data. So that also, that logic of either inserting or updating will be also defined in the ETL process. So you have to think about a lot of things while extracting, transforming, and loading the data. So please go through this fundamentals, and I think we have covered half of the fundamentals. Now I think we have half of the fundamentals still left, which we will be discussing tomorrow. Okay, guys. So I will stop it here for today. Do you have any questions? Jaya, just give me 2 minutes. I'll be joining you. Yeah. So any questions for today?
No, Raja, I'm fine.
Okay. So I hope everyone else also doesn't have any questions. So if you do have any questions, just feel free to let me know or email me. And just please go through this document at least once. And any document is not so complete, not only mine. So what I would recommend you is, if I listed some topics here, okay, I gave some information, but I want you to research some more on each topic and understand enough of it so that we'll be on the same page. So if I say data integration, I said like a couple of lines here, or maybe 3 sentences. But if you Google it, you might get very useful information. So just if you're learning any topic, just go in depth of it. That helps you to understand the concept on the whole. Okay, so I have to rush. I believe you don't have any other questions.